All right, peeps, here we are. We're going to be talking about photochemical smog. Yeah, one of those great topics to talk about, right? Let me see if I can expand that out a little bit. Yeah, trying that out a little bit, moving that there, moving that here. So, photochemical smog. Smog, it's basically fog and smoke. And photochemical is where it interacts with, it basically interacts with the sunlight. So sunlight interacts with the smoke and fog. So, all right, here we go. Urban air pollution. It doesn't take you much to figure out like smog is going to be worse in cities. So, yeah, that and like high up mountains, valleys where there's the wind has trouble getting into. That way, the fog just sits there and settles. So, estimates are 1 billion people are exposed to outdoor air pollution per year. So, especially with you start looking at urbanization with people just moving towards cities the last 150 really since the industrial revolution. So 1 million people die per year because of smog. So that's just who dies. I mean, there's quite a few other people who actually have a lot more health benefits because of it. So 2% of GDP is lost by air pollution in MDCs, 5% in LEDCs. So, more economic developed countries, um, like 2% of their what GDP is gross domestic product. It's basically what you make that sells abroad that makes you money. So think about whatever you sell like to make you money. That's what GDP is, gross domestic product. Whatever you sell abroad to make you money, um, you lose 2% of it just from smog. All right. 5% for low economic developed countries. So MDCs make more money, LEDCs make less money. Um, that is what GDP is, gross domestic product. In NATO, it is recommended that every country spends 2% of their GDP on national defense, Army, Navy, Marines, Air Force, you name it, Space Force, everything. Like, so whatever you sell as a country to make money, like you make like $100 billion per year, you should be spending 2 billion of that because that's 2% on your defense, national defense, if you're a NATO country. um, NATO countries tend to be all the countries in Europe and North America. So well, United States. I think Canada is part of NATO, but don't quote me on that. Over 90% of urban air pollution in LEDCs are from old motor vehicles. So when you see like a safari or a country like a National Geographic or something online about some like a faraway country that looks kind of um, not as economically well off, and you see like their cars are older model vehicles and they're not as well regulated as they are in the United States. So for air pollution, so they've got like a straight pipe exhaust, which means the exhaust comes right out of the engine and all the air pollution goes right off into the air. Unlike here, where it goes through a catalytic converter and some other things that help regulate how much that exhaust comes out. So, um, air pollution can be from chemicals, particulates, and biological matter. Not everything for air pollution is because of like car combustion engines. Obviously, if a volcano explodes, that is natural, and yeah, it's still going to mess up the air and like smog and whatnot. So yep. Pollen count can do the same, like for here in New England. Um like when it's May, if you've got a white car, it's going to be yellow for that month because the amount of pollen that's coming out of the trees is insane. And that can affect air quality as well for air pollution. All right. Primary pollutants emitted directly from a process. Example, carbon monoxide. You can point to like incomplete fossil burning. Yeah, that's going to come from car exhaust, and that's coming from that electrical plant chimney. You know, Carbon dioxide, again, coming from the exhaust, coming from the chimney. Unburned hydrocarbons. Yep, same deal. Nitrogen oxides as well, coming from exhaust electrical plants. Sulfur dioxide from burning coal in electrical plants, also industrial sites. Particulates, soot. That's like soot is basically the stuff that comes out of your chimney. So, which can be from like obviously burning wood, building sites as well, and forest fires. Forest fires. If some of you this summer of 2023 in New England have noticed, we've got a lot of haze in the air. And it's not from any forest fire near us, it's from forest fires way off in Canada. Not as far in Canada as you think, Quebec. And they just smoke blows down towards us. Secondary pollutants. Primary pollutants undergo a reaction with chemicals in the atmosphere. Examples: tropospheric ozone. So, yep. Let's talk about that. So, the primary pollutants undergo a change with like what's around, basically. So, in the troposphere, the ozone, studied it previously. The ozone undergoes change and it does things. So, particulates produced from gaseous primary pollutants. So, in perioxide, let's see if I can pronounce this right. Peroxia acetyl nitrate, PAN. Define photochemical reaction, if you can. All right. Uh, all right. So we talked about tropospheric ozone up there. 10% of the ozone is in the troposphere. It is 2,000 times greater than carbon dioxide as a greenhouse gas for just trapping heat. So one particle of that ozone in the troposphere is 2,000 times better or stronger at trapping heat than one particle of carbon dioxide. Formation of tropospheric ozone. This is where it gets a little bit funky. Fossil fuel combustion produces. Let's do that here. Fossil fuel combustion produces hydrocarbons because not all the fuel is combusted. So yeah, when they're burning fuel, like in a like a gas engine, the engines have gotten a lot better at burning it all. I will say that, and I don't think it's really much for the environment. It's just because, like, when you are not burning all the fuel, you're letting just free horsepower go out the window. And a lot of those car manufacturers are like, no, you know what? I want to be able to tell people that this engine has the most horsepower that I can get out of it. So that's why they burn fuels more completely now versus like a 1960s muscle car. So let's see. Hydrocarbons, not because not all fuels combusted. Nitrogen oxides from the nitrogen and oxygen in air react during combustion. They just do. All right. This makes tropospheric ozone when this happens. The nitrogen oxide combines with the oxygen to form NO2, which is a brown haze in cities. So when you look out at Hartford, like from a distance during the summer, you'll see there's a haze, but it's got like somewhat of a brownish tinge to it. So this breaks up, then reforms photochemical reaction, then makes ozone. Um, so it just constantly goes through that cycle, basically. So, yeah. Possible effects of ozone. All right. Ozone is a toxic gas plus a good oxidizer. So it's going to rust things quite a bit better. It's going to degrade materials quite a bit faster. Plants absorb ozone, but damages the chlorophyll and decrease productivity. You'll notice this with leaves that start to turn yellow. So the leaves are where the chlorophyll is, and with ozone, it absorbs it, but it damages the chlorophyll, so they no longer really the leaves don't work as well as they should, and that's really how plants get their energy. So plants basically become sick, and when you're sick, your productivity goes down. Breathing difficulties, irritation to throat, eyes, and nose. My mother in law deals with this. She's got bad asthma. Guess what? She was in San Juan as a kid, and my mother in law's family was pretty well off. They had the city house and then they had the country house. And yeah, they moved my mother in law from the city house to the country house because the air was better for her asthma. Ah, yeah. All right, let's go down here. Damages rubber, plastic, and cellulose. So remember how we talked about oxidizing? Oxidizing just doesn't affect metal. It also really damages the rubber, plastic, cellulose. Cellulose is the casings on hot dogs, that keep all the meat inside, and it's also too it's like the skin of plants. So yep. Bleaches fabrics. So yep, if you got that shirt that's just really that color, ozone kind of does the damage on it. Makes it more dull gray. Black shirts too. If instead of it being that popping black, it makes it more like matte black. So formation of particulates, burning. Draw a fire, burning anything. All right, please. I want to see a little bit of art with your notes. So yeah, diesel engines. Yep, that will do it too. If you ever see rolling coal, on the highway, let me see if I can get a video of that. Let's type in here. Videos. Oh, huh. Yeah, here you go. Let's see if it says it backfires. Oh, come on. Give me some, let me see this. No, all right. You're not going to let me do it. Sorry. We're going to videos. Okay, here we go. Insane road rage with rolling coal. Let's see if we can just get. All right. Let's see here. See if you can see it with the exhaust. Let's get a better video. Sorry, I'm looking for rolling coal. This one. Come on now. Wee. Okay. Yeah, that's kind of rolling coal. Boom. Just when you hit basically, that's a diesel truck. Diesel engines are different than gas engines. They don't have spark plugs. They just combust with pressure. And when you hit the fuel or pedal really hard for acceleration, you'll see it basically cleans out all the exhaust. And a lot of these guys tamper with the exhaust too to get rid of it so that it just comes straight out. And that black smoke you see is processed fuel, so it's kind of stupid in a way. But yeah, it makes this big black cloud of smoke behind these cars. So yep. So a little bit of side note there. Off of diesel engines. What percentage of 18-wheeler trucks use diesel engines? I would love for you to figure that out for me if you could. So what new types of diesel fuel are there? Yep. Let's look at that. Particulate dangers. Our bodies don't filter them, just accumulate them with breathing. So your bodies don't keep them out. Like when you breathe it in, you just accumulate them, and it just it's like your body's like a sink for them. So it just over time, it just takes up more and more. No, you find this hard to believe, but many are carcinogenic for particulate dangers. Yeah, you breathe them in, and they're toxic, and they're more likely to cause you cancer. So, so cover crops, decrease productivity. Yeah, so like if you've got these particulates and they're just covering over the leaves and like your plants, that sunlight is not getting through, doesn't do you as much good. So, formation of photochemical smog. Warm, sunny days with traffic. So it's one of the reasons you don't see it much during wintertime because wintertime is cold, at least here in New England. Um, so yeah, like so when here in Hartford, like it's in a river valley. So automatically, there's very humid, very dense. And water vapor is a greenhouse gas. It's one of the reasons why you start to see that just like fog and like that humidity to the air during the summertime. You throw in there those pollutants, like and yeah, you're more likely to form that smog, because you get that like those particulates in the air with the moisture. That's how you get your smog. Warm sunny days with traffic. Why? Because traffic produces more. So vehicles, forest fires, etc. So forest fires, winter tends to be more of like a wet season and cold season, which puts out fires. But also too, so during the summer it's easier to have a forest fire. But also too during the wintertime, the breeze blows, it's colder, so that the particulates don't stay in the air as long, which is another reason why for forest fires you're not dealing with like the haze that you are during the summertime. Um, Smog makes up VOCs, volatile organic compounds. PANS. Oh, there's that word again. I have trouble pronouncing. Peroxyacyl nitrates, ozone aldehydes, carbon monoxide, nitrous oxides. So primary pollutants occur with morning afternoon noon commutes. So in the morning, you drive to work, and then in the afternoon you drive home. So the prime time for smog is early afternoon. Why? Because it's the morning commute. The temperature is still kind of cool. Also, too, that emissions need to get into the air. By the time that like it's afternoon, they're in the air. The sun's hitting. It's perfect time for some afternoon smog. So, photochemical reaction needs the sun too. In the morning, the sun's coming up. In the evening, midday, it's already up there. So give two reasons why you are more likely to breathe smog on a school bus commute compared to a high earning corporate employee driving home in a Benz. Well, for one, you are driving home at the perfect time, like when school gets out at 2:15, 2:30, and now you're riding on a school bus home, you're all excited to go home, right? Um, yeah, okay. That's the perfect time for it's 3 o'clock for that smog hour. Also, too, on a school bus, your windows are down. In a Benz, they have this air filter and air conditioning, so their windows are up. I will say this during summertime, hopefully you're not going to school on a school bus where the Mercedes Benz owner is driving in during summertime. So he's got like the summertime smog, like prime season for it. You unfortunately are going through it the prime time. Is smog more common in summer or winter? Summer. Things that affect the amount of smog, the amount of wind. It's windier here in Hartford area during the winter time than it is during the summertime. Valleys. Hartford, you are in a river valley. Guess what? More smog. Rain. So yeah, rain actually does help out, like knock down smog. Unfortunately, then it becomes acid rain. But hey, we won't go into that. Not right now. So like we've had these horrible forest fires up in Canada this summer of 2023. that smoke comes down right into Hartford, forms some beautiful smog. It's also been like the wettest summer I've ever remembered. Every other day it rains, which is probably a good thing because it knocks a lot of that smoke out of the air. Elevation really helps. So, like, unfortunately, Hartford, guess what? You're closer to the sea level. You're in a valley. You get, socked in with smog. If you are up in the Litchfield Hills, there's not as many people, and there's also too your higher elevation, so you're not getting the smog that Hartford does. So yeah, population density. Yeah, more people, more running around, more combustion engines, and as a result, more smog. Fossil fuel use. Yep. The more we use gasoline, and look, it's me and you with commuting, but it's a lot of the stuff that we order too. Those Amazon trucks aren't exactly running on, batteries at this time of, summer 2023. They are trying to do that with the future. But the trucking industry too, to get something from A to B, and I'm not blaming the trucking industry. Lord knows we need truckers and transportation, but it takes fuel to get something from A to B. It doesn't do it for energy free. So, yep. Thermal inversion. Warm air over the polluted ground that keeps the air from rising. Oh, let's get that up here. Yeah, bring that one here. All right. Thermal inversion. Warm air over the polluted ground that keeps the polluted air from rising. This is what we talk about with an inversion. You know how cold sinks and then heat rises, right? So here you have a nice blanket of, like smog, right? But as it gets warmer, it should just go up and leave the city. Great idea, right? Unfortunately, what happens is if there's a warmer set of air above it, it's going to trap it right there, like in the city, and it's going to be trapped for a while. So thermal inversion basically traps the smog at ground level. So rain knocks smog down, which is a good thing. It goes and hits it right out of the air. Wind blows the smog away too, which is why rain and wind are our friends. In CT, we are trying to clean up our air. Our state has put truck emissions low, yet that's why, like for emissions test for your cars, yeah, they got to make sure they're not like putting out that nasty smog. Yet there is a large city to our southwest that contributes to air pollution, smog, and then predominantly northwest winds blow it onto us. What city is this? Let's see here. Map of CT. Yep. Oh, you know what that city is? That city is called New York. Yep. All the pollution from like New York with those like western winds, especially for the southwest, blow right up into our state. So, yep. So that answers that one. NYC. You can just put down 3 letters if you want. London type smog. First time the word smog was used. Yep, it's pretty informative. Smoke and fog. You put them together, you got smog. So, yeah. London is historically foggy. They talk about London fog all the time. It's just the way their little micro-ozone is. And so Britain is also coal rich. So when you start looking, you're like, okay, what do I have to make electricity? Industrial revolution. Like, am I going to be burning natural gas? I don't really have much of that. Am I going to be burning oil? Nope, don't have much of that either. I do have tons of coal though. So yeah. So you heat your homes and electricity by burning this coal. Um, Not a photochemical reaction, just straight up air pollute for this. So it doesn't form like this chemical reaction with the sun. It's just fog with that primary air pollutant, and that's what forms, London smog. So this is a big problem in the 1950s, I believe. You can correct me on it. Also the 1960s, I think, and right after World War II. And it was so bad that the Queen and Winston Churchill had to get involved and start doing some stuff with the coal power plants to clean them up. So, all right, for next part, right here. Write these scenarios on the left and say if they are altering human activity, regulating human activity, or cleanup. Drive less. I'm going to say that one's altering. Um, Government regulates gas tax. Well, right there is the word regulate, so I'm going to say regulating for that one. Boston, big dig. Replace highway with park. Ooh, I'm going to say that's cleanup, I think. Purchase renewable energy. That's altering, I think. Use public buses. That is altering as well. Government regulates need for catalytic converter on cars. Well, there's that word regulating again. Reforestation, I think, is cleanup. Ask governor to increase renewable energies. That one I think would be regulate. Government regulates low sulfur diesel fuel. Yeah, so that's another one that would be regulate. Yep, and right there, peeps, that is 6-3 because right down here is 6-4. So, yep, good job, and hopefully you're doing awesome. Adios, bye.